In this video, we will talk about the normal distribution. The normal distribution is sometimes called as the Gaussian distribution. Right? So a Gaussian distribution or a normal distribution has a shape that is curved. So it looks like a bell. It's a bell-shaped form, just like in the given illustration. In this video, we will tackle the properties of a normal distribution or a Gaussian distribution. The first property of the normal distribution is the values of its x are limitless or boundless. What do we mean by that? When we say boundless, this means the values of your x can increase to the right side and can decrease to the left side without ending, without limit. The second property of a normal distribution is it's asymptotic. So when we say asymptotic, that means the left side tail can extend to the left and the right side tail can extend to the right but can never touch the x-axis. It will never be at point zero. Third property of the normal distribution is about the mean, the median, and the mode. The mean is denoted by the symbol which is mu. Okay, that is the mean. The mean can be found at the highest point of your curve or at the peak of your curve. So if this is the peak of your curve, then this will be our mean. Take note that the mean and the median and the mode are both found at the center. This gives us the fact that the mean is just equal to the median and is also equal to the mode. Or simply, the mean, the median, and the mode are of equal value. Now, let's go on to the fourth property of a normal distribution. So a normal distribution is symmetric. When we say symmetric, the left side and the right side of the curve are equal. So from the mean or the entire area in the left side is just equal to 50% or okay, that's 50% or zero point 0.5. And the area on the right side also is equal to 50% or zero point 0.5 or zero point 0.5 as well. If we will combine this, it will give us the total area under the normal curve, which is equal to 100% or simply 1. Now, let's talk about the inflection points of a normal curve. The inflection points tells us the change of the concavity of the curve, and that can be found one standard deviation away from the mean. This is the mean, so one standard deviation away from that, this will tell us the location of the inflection point. This is our mean, one standard deviation away from that, this is also one of the inflection points. So all you have to do to remember the location of the inflection point is it can be found one standard deviation away from the mean. All right, that's on left side and one standard deviation away from the mean to the right side. Next that we will be talking about is the empirical rule. So what do we mean by empirical rule? The empirical rule is also called as the 68.3%, 95.4%, and 99.7%. This is what we call the empirical rule. Now, let's tackle them one by one. When your data falls one standard deviation away from the mean, that's here, from here, and here enter here, the area is equal to 68.3%. Now let's shade that one with color yellow. So this particular area, this shaded part in here is equal to 68.3%. On the left side, that's 34.15, and on the right side, that's also 34.15. Adding this, it will give us 68.3%. Next, let's go to the 95.4%. When your data falls on two standard deviation away from the mean, that's here up to here and here until here. All right, for a while, I think I'm having trouble with my, okay, let's go. Here until here, then the area is equal to 95.4%. So let's shade that one with this color. So when it's 95.4%, that's meant from here until here, the area is 47.7%, and here until here, that's also 47.7%. Now, going on to the last percentage, we have the 99.7%. When your data falls on three standard deviation away from the mean, that's here until here, and here until here as well, the total area is 99.7%. So let's try to shade that one with color pink in here. Now cutting that into halves, the left side is equal to 49.85%, and the right side also, that's equal to 49.85%. So these are the properties that a normal distribution has. Let's try to review. First, it's boundless. The x values can increase or decrease without end. Second, the tails are asymptotic. The left side tail can extend to the left, and the right side tail can extend to the right, but will never be at point zero, but will never be able to touch the x-axis. Third, the mean can be found at the peak or at the highest point of your curve, and this is equal to the mean, to the median, and the mode. Okay, the mean, the median, the mode are of equal values. Next, a normal distribution or the normal curve is symmetric. The left side is equal to the right side. The area on the left side is 50%. The area on the right side is also 50%. Adding them implies that the total area under the normal curve is 100%, or simply 1. Next, the inflection point can be found one standard deviation away from the mean. And the empirical rule tells us that when your data falls one standard deviation away from the mean, the area is 68.3%. When the data falls two standard deviation away from the mean, the area is 95.4%. And when the data falls three standard deviation away from the mean, the area is 99.7%. So I hope that you have learned something. If you do have questions or suggestions, feel free to comment it down. Goodbye and God bless.